Hello and welcome to a new video about controlling Arduinos. Last time we connected our Arduino the first time to our computer, and we uploaded our first program to the Arduino. We told the Arduino, please do nothing, and it did well. Okay. Today we want to upload something more meaningful, a little bit more meaningful. A typical starter sketch. This is how a program is called in the Arduino world, sketch. It's a program. So let's have a look at our Arduino once again. Here is a LED which is already built in. Okay, and we want to make this blink. This is our task, that it is turning on, turning off, turning on, turning off. And I can tell you, on this board, this LED on the board itself, it is connected to the in and output pin number 13. I told you, here are a number of in and output pins. So, and on 13, pin number 13, this LED is also connected. Okay. So, actually, what we want to do, we want to turn on pin number 13, wait a little bit, turn off pin number 13, wait a little bit, turn on pin number 13, wait a little bit, turn off pin number, so that the impression is that this is blinking. Okay, so let's start. Let's call our Arduino IDE. We are opening it. It is opening the last available sketch, the last sketch we worked with, because it is just assuming we want to proceed. However, we do not, and so we select File New, and then we have a new sketch. I will immediately save this under a name. I will call it to blink. That's the usual name for this sketch. Blink sketch, back. So we said we need to turn on and off our pin number 13. How do we do this? Well, there is one command which can be used, and this is digital write. Okay? Digital write is writing a digital output. This is a decent name for this, right? And it needs the following parameters. First, we need to tell which pin number. Set this is pin number 13. Pin number 13. And then we need to tell if we want it to set to 5 volt, 1, or set it to 0 volt, 0. So we want to set it 1. Okay. Next thing is what we want to do is we want to wait. Okay, there's also command for waiting. It's called delay. Delay, and then the argument of delay is simply how many milliseconds we want to wait, and we're waiting half a second. Wait half a second, and then we're turning off the output again. 0. That's it. And then we are waiting again 500 milliseconds, and then we're turning on the output again. Wait a little. This is not necessary, because I told you the loop, if it's finished, it will start over again. So if we are here, it will then write again 1. So this is everything we need. We need to keep in mind the loop is running over and over again. Okay, this is our program. Turn on, wait, turn off, wait, and then we're starting up again at the first line. Turn on, wait, and so on and so on, until eternity. This thing is patient. There's one little thing missing. I also told you these in and output pins, they are multi-purpose. So this means they can be an input or they might be an output. And we have to tell if a decent pin is an input or output. This we can do in setup. This is a typical task we are doing in setup. So in setup, we are calling the command pin mode, and this pin mode command gives now, with this you can determine if something is an in and output, and it also needs the pin number, so pin number 13, okay, and this shall be, you just have to write output, and output. This we can also remove now. Save. This should do the trick. Okay. Let's connect our Arduino to the computer. Bim, bidim. Oh, and upload the sketch. Book. Let's see what is happening. Blinking, blinking. You see? Whoop. The thing is blinking now. The LED built in is blinking with 1 second time period. Half a second on, half a second off. What if we want to do it faster? Let's say 200. Upload. Upload. Let's look. Blinking faster. Blinking faster. Really it is working. Okay? So this is the typical blink example. Two things are not that nice. You just have seen that if I want to change the time, I would have to change 2 lines. I really don't like that, because I'm lazy. This is why I define now a so-called compile time constant with a hashtag. Now it's called hashtag. Define, and then I can select a name. Select a name. I will call it blink time. And then I select which value I want to have. This, now I set it to 1000. Okay? And everywhere I'm using inside the sketch then blink time, this will be replaced by 1000. Okay? So it's not really a variable. It is not using up any space. It's not a constant. It's not using up any space in program memory. It's just replaced. It's like if you do a search and replace function. Everywhere you find this, replace it with this, and then translate it to machine code. Okay? This is the big benefit of a compile time constant, that it does not use any space at all. Okay? Upload. Let's see what is happening. Blinking slower. Okay? Exactly what we have expected. So this is working. One thing is also still not nice, I would say. We just written here 13. I can tell you, on different Arduino boards, this built-in LED is connected to different LED numbers, to different I/O numbers. So here on the Uno it's 13. There are other boards out there where it's connected to 7, and then I would have, and if I want to download the sketch to several boards, I would have to adapt my coding to the used board. Luckily for us, such compile time constants, like we've done here, are there also naturally. Okay? They are already built in as well, and they can change its value depending on the board I'm using here. So if I'm using here a Arduino Uno, a compile time constant might have a value. If I'm using Arduino Mega, then it might have another value. But the constant name is the same. And the constant name for the built-in LED is called LED built-in. It's even getting blue. Okay? So if wherever I'm using this LED built in, it will be replaced by the correct number for the board I'm compiling. Zack, zack. Yeah. Download, and it still has the same function. Yeah? It still has the same function, still working. Okay? If I change this to 100, I just have to upload it, and it will immediately flash very fast. There you see. Now it's easy to maintain. This is quite a nice sketch now. This is a quite nice blink sketch. Okay. What you could do for practice is that you change the period of blinking, yeah? So that you turn it on longer time and turn it off just a short time. Or turn it on short time and turn it off a longer time. Yeah? So make it a little bit asymmetric. Yeah? This would be a nice exercise to do. Next time we are going to use not an internal LED, we are really using something external. We will use an external LED light emitting diode and turn this on and off. You know, pretty much the same thing we have done here, but with an external one. Yeah? So we are really going now off the board to an external circuit.